Colleagues, remember a utility function just measures utility, which is satisfaction. Okay, colleagues, utility is satisfaction. So this is our utility function, okay? Square root x1, x2. You are further told that x1 and x2 represent bread and sausage, respectively. So x1 is bread, sausage is x2. Number 1, part A. Determine the utility maximizing quantities of bread x1 and sausage x2 that the consumer must purchase. Okay, so here we're talking about this thing that is called the Marshallian demand function. Okay, Marshallian demand function. Okay, the Marshallian demand function, that's going to show us the utility maximizing quantities the consumer must engage in. Okay, so you're going to follow these steps. Okay, you're going to follow these steps to get these Marshallian demand functions. Okay, so the first step is step 1. Get the marginal rate of substitution and the budget constraint equation. Okay, that's step 1 here. So part A. Get marginal rate of substitution and the budget constraint equation. So we'll start with the budget constraint equation. Colleagues, a budget constraint equation, it's just showing you the quantities of goods you can buy with the income that you have. Okay? The quantity of goods that you can buy with the income you have. So the budget constraint equation, because this is one of the easy one to make. Remember, I is income. PX1 is the price of sausage. X1 is the quantity of sausage. Plus PX2, this is the price of bread. X2, that is the quantity. Okay? So remember this. I, income. P1, price. X1, quantity. P2 again, this is price. X2 is quantity. I hope we're okay with that, colleagues. Alright. This is what these letters mean. Okay. And after you get your budget constraint equation, you also get the slope of the budget constraint equation. So you say slope of the budget constraint equation equals negative PX1 over PX2. Okay. Why there's a negative? Because the budget constraint equation is a line like this. It slopes downwards like this. It's just telling us how much of X2 we need to give up to get X1. How much of bread we need to give up to get sausage. Okay? Yes. So this is the slope of the budget constraint equation. Alright? Yes. This negative in these tabulations, you won't need to use the negative when you're doing these tabulations. But I just put the negative there to illustrate to you that this slope, the budget constraint line is a downward sloping line. So usually the slope is negative. Okay. So these are the first things we need to get. Then we also need to get the marginal rate of substitution, MRS. Okay. Do not worry, there's a video on this marginal rate of substitution. Okay. It is just the trade-off rate. Okay, colleagues? Trade-off rate. Trade-off rate. You have the indifference curve like this. Okay. You have x2 here, which is said x2 is what? X2 is sausage, so you have sausage here. X1 is bread here. Okay. So as you go down this curve like this, what is happening? You're giving up sausage to get bread. That's what the marginal rate of substitution is. It's just telling you how much sausage you give up to get bread. Okay. So when you combine this utility curve and the budget constraint line, where these two meet, this gives you the maximum satisfaction you get. It tells you what the amount of sausage and the amount of bread that will give you the most satisfaction. Okay, colleagues? Where the marginal rate of substitution, just remember this, where MRS, marginal rate of substitution, equals the slope of the budget constraint equation. That gives you the utility maximizing quantities. Meaning it tells you when you get these two quantities, your satisfaction is going to be the most. So now here, this is where we need to pay attention, because in this marginal rate of substitution, this is where the calculus comes in. So remember our utility function is this. X1, X2. To get our marginal rate of substitution, we need to derive this function. So first things first, we remove this root sign. Okay, remember this root sign is same as the power half. Hello? To get rid of this root sign, it becomes like this. X1, X2 raised to the power half. Okay, colleagues? Laws of indices. Okay? This comes from the laws. Whenever you see a root sign, convert it to the power half. Okay, colleagues? When you see a root sign, convert it to the power half. Then after you do that, distribute this half power to each term. E. So what I mean, you have x1 to the power half, x2 to the power half. x1 to the power half. X2 to the power half. Okay, colleagues? This is what you need to do. Any questions before I move further?
Sir, is that the standard utility function? U equals square. Okay.
The utility function differs. Sometimes they might give it to you like this. saw in example 1, they brought it like this. U equals xy. Okay. So they can bring it in different forms. Okay. Just up to you to know how to deal with each form. Okay. Once we've simplified our utility function. Now we need to derive it. Okay. So we have to get the marginal utility with respect to xy. This is the additional satisfaction you get when you consume one more unit of x1. Okay, colleagues? That's what we mean when we say marginal utility of x1. So it means you are deriving this function with respect to x1. So we're going to put it like this. Deriving the utility function with respect to x1. Let me convert these into decimals so that it makes life easy. Because when you're dealing with fractions, so half is the same as 0.5. X the power. You see that working with decimals is less of a headache than with fractions. Okay. So we are deriving this utility function with respect to x1. So since these two are attached, it means when you're deriving it with respect to x1, you're only going to derive x1. Okay. So we derive x1 according to differentiation. Remember how we derive? Multiply the power with the number in front of the letter. So this is 0.5 multiplied with the number in front of the letter, which is a 1. 0.5 times 1 gets 0.5. X to the power 0. x1. So remember this 0.5. After you've multiplied it with the number in front of x1, you're going to subtract it by 1. So you say 0.5 minus 1. You get negative 0.5. So you get x1 to the power negative 0.5. Because we've subtracted the 1 from this 0.5 here. Okay. And then you just write x2 as it is. x2 to the power 0.5. Any questions? Okay. Get the marginal utility of x2. The additional satisfaction you get when you consume one more unit of x2. So you can say mu x2. You are deriving your utility function with respect to x2. So this time it means you're only deriving this x2 here. So what you're going to do, you're going to say 0.5 multiplied by the number in front here, and get 0.5. Then the x1 just stays as it is. x1 the power 0.5, then you have x2, So remember, subtract 1 from this 0.5. 0.5 minus 1, you get negative 0.5. Okay, colleagues. That's getting the marginal utility. So as we said, the marginal rate of substitution MRS equals mu x1 divided by mu x2. So we're going to bring our information here. So mu x1, remember it is 0.5 x to the power negative 0.5 So we simplify this. The 0.5s cancel each other out. So you're going to say x1 to the power negative 0.5 divided by x1 to the power 0.5. You can write it down here. So for everybody's sake, so that we're following clearly. So you say x1 the power negative 0.5. According to the laws of indices, colleagues, if you are dividing the same bases, you subtract the exponent. So x1 to the power negative 0.5 minus 0.5 e. We're just subtracting these two powers here. Then for x2, you're going to have 0.5 minus negative 0.5. We are just subtracting the powers here. And these powers here, we're just subtracting them. So negative 0.5 minus 0.5, you get negative 1. So you have x1 to the power negative 1. 0.5 minus negative 0.5. Negative and negative make positive. 0.5 plus 0.5, that is 1. So you have x2 to the power 1. Okay. Then to simplify this further, remember, if you've got a negative power, you just bring it to the denominator. So you're going to have x2 to the power 1 over x1 to the power 1. Okay. This negative becomes positive when once it reaches the denominator. Any questions, colleagues? Okay, step 2, so that it's uniform from the other video. Step 2, equate the marginal rate of substitution with the slope of the budget constraint line and solve for x and y. So step 1, remember, we got the margin rate of substitution, the Bajek's straight line, and we got the slope.
Now step 2,
we need to equate the slope and the Bajek constraint line.
This is
what gives us the maximizing satisfaction. Okay. So we say step 2. Equate MRS, marginal rate of substitution, which is the trade-off rate, which tells you how many sausages you're giving up to get bread, with slope of the Bajek constraint. The slope of the Bajek constraint line is also telling us the same thing. How many sausages we're giving up to give up bread. This is what I mean. You say you start like this. Marginal rate of substitution, remember, it's MUX over MUY. This is the marginal rate of substitution. Or MUX1 over MUX2. Equals PX1 over PX2. Okay. This when you show it by a diagram, this is your Bajek constraint line. This is your indifference curve. So where these two touch, to tell you how many sausages you need and how much bread you're going to need, so that you get the most satisfaction. Okay. This expression is what it represents. A diagram. So if you remember, colleagues, MUX1 we said was X2. Okay, remember when we simplify it here. Okay. MUX1 is this X2 which we got here on top. MUX2 is this X1 at the bottom. Okay, colleagues? Yes. So we're going to say X2 over X1 here PX1 equals PX2. So we cross multiply, you're going to get PX2 X2. We were cross multiplying here like this. Then equals PX1 X1. Colleagues, what this expression is telling us here is you need to spend the same amount on sausages and bread to get the most satisfaction. Okay, colleagues? What this is saying, you need to spend the same amount on sausages and bread to get the most satisfaction. Okay? So that is the end of step 2. Step 2, you have to get this expression, which is just telling you to get the maximum satisfaction, spending the same amount of X and Y. So we go to step 3. Any questions before we go to step 3? I just want everything to be the the same as in the previous video. So step 2, before we say we're done with step 2, just need to do one more thing. For step 2, so here, when we get this expression here, px2, x2 was px1, x1, make x1 and x2 the subject to the formula. So we say if we make x1 the subject to the formula, we're going to say px2 want to make x1 the subject to the formula. So how do we do that? We divide both sides by px1. Therefore you're going to say x equals p x2 over px1. Then for y you do the same thing. For x2, divide both sides by px2 and you're going to get this expression. x2 equals p x1 over px2. So after you get this expression in step 2, just make x1 and x2 the subject of the formula. Okay. So remember with deriving the steps, you have to just master these steps. Okay. I can go to step 3. Substitute your values for x and y back into the budget constraint equation. So remember our budget constraint equation was this: I equals px1 x1 plus px2 x2. Okay. So substitute your values for x and here in this case x1 and x2. So x1 equals px2 x2 over px1. So here in our budget constraint equation you're going to say p x1 and you substitute it for p x2 over p x1 like this. These px1s cancel each other out. So you have px2 x2 plus p x2 x2. Okay. You're adding the same px2 x2 plus px2 x2. So you're going to get our value 2 px2 x2. Okay. So our expression for the Marshallian demand for x2. So in this case, you make x2 the subject of the formula. So divide both sides by 2px2. So these cancel each other out. x2. So you want to buy x2. This is the formula you need to use to find out how many x2 sausages. How many sausages can you buy with the income you have and the price of sausages? Okay, colleagues, this is what this is telling us. This is the Marshallian demand function. It's telling you how much sausages you can buy with the income that you have and the price of the good. Okay. Yes. You're going to repeat the same process again. Okay. Now I've been writing so much, so my hand is really tired. I'll just do a bit of this part, step 2 here. Okay. Because these things are like mirroring each other. So here x2, remember x2 is the same as p x1 over px2. And the px2's cancel each other out. So px1 x1 plus px1 x1. We're also going to get 2 p x1 x1. Make x1 the subject of the formula. You're going to say that x1 equals I over 2p x1. So this is how much bread you can buy with the income that you have and the price that you have. Okay, colleagues, that's what these functions are telling us. Okay. Any questions? So we're done with part A. Any questions?